Yeah, welcome to today's video. Yes, if you have really watched our previous video, then you are doing well because you are trying to build a concept so that you can master sets and everything around it. As I said in the first video, a set is something that is going to stay with you from now on and in your journey in the field of mathematics, right, and in other fields as well. Yeah, so multiplication of sets. It's quite, I would say on my end, I would say it's simpler than what we learned for the addition, because for addition there you have to follow some conditions, right? The conditions are that those that are under the square root, right, they don't interact among themselves, and only those that are outside interact. But before they two outside can interact, we said what should happen. The their square roots must be the same. So watch the previous video for addition and subtraction to see how that concept worked. Now for multiplication is quite easy, as I said. So let's say we have two numbers, right? Two numbers, right, that contain sets. So we have, let's say, a root b multiplying c root d. So simply for multiplication, what you have to do is that those that are outside, right? Those that are outside, A and C are outside. So you multiply them, they multiply themselves, and then square root of those that are inside the square root, right? This time they interact, so they multiply among themselves. So you put them under one umbrella as well. So when you do that, what you have outside AC, a square root of BC. That's what you get at the end of the day. So simply put, that's how multiplication works. The simplest form that you can see for multiplication is a number a root b. So yeah, but like it's like a times root b. So a times root b is the same as a root b. That's what we said in the first video, where we say it's kind of make it clearer and simplify, but they are multiplying. But what basically happens is that this same multiplication thing is happening. We said when you have a number like the a times root b, we said this a is the same as a root 1 times 1 root b, because we said if nothing is in front of it, there is 1. This one too, if nothing, any root is not there, then it's root 1, because root 1 is 1 and 1 times any number is the same thing. So what we have at the end is that those that are outside, right, following the multiplication rule, right, those that are outside, a and 1 are outside, so a times 1 square root of those that are inside as well, so b and 1 are inside, so you have b times 1. So they are multiplying. Then at the end of the day, you have what? A root b. A root b will be final answer, because a times 1 is 1 and then b times 1 is also 1. Yeah, that's how to do the simple multiplication. So an example is we have 2 times root 3. So this will simply be 2 root 3. Like as simple as that. So if you see 2 root 3, it's like 2 times root 3, but we don't actually write the multiplication. But then the previous step is the same thing. So let me just use actual numbers to illustrate the same concept. It's the same as 2 root 1 times root 3. And root 3 is like 1 root 3. So if you have that, you're going to have what? 2 times 1, which are outside, square root of those that are inside, 1 times 3. Those are the ones that are inside. So you have 2 root 3 at the end of the day. That's simple and then quick to actually keep. Yeah. So let's actually look at another example. Another example of sets. Now in this case, let's look at this example of square root of 3 times square root of 6, for example. So square root of 3 times square root of 6, right? We said if there's nothing in front of them, it's like 1 is 1 at the front. So we have 1 times 1. Those are outside, and those that are inside is 3 times 6. So if you have that, 1 times 1 is 1. Square root of 3 times 6 is 18. At the end of the 1 times any number is the same number, so with 18. Now square root of 18. Now we have used multiplication to have this answer. After you have your answer, what should happen? You now use reduction. Maybe reduction might not work. If it's a prime number, it still go back to the previous concept, the previous video that we talked about with 18. So we have to do reduction for this with 18, right? A simple way is to do it well. So you have your calculator. I have mine, still have mine. So it's just put square root of 18 to just be the reduction for you. I have 3 roots 2. So this one will become 3 square root of 2. We have explored how to do the reduction, right, in the reduction video. So you go back to that. For the addition and subtraction, we understood reduction. When we go to addition, everybody that followed, right, knows what happened and why we are doing the calculator stuff. So as to make the thing simpler for you, you actually understand how it works. Yeah, watch those videos and understand how the thing actually works. So moving forward, you also on the same on the same page at the same level with us. Yeah. Um. Let's look at another example. Now we have 2 root 5 times let me say 3 root 10, like as an example, 3 root 10. So what do I have? So we say those outside multiply themselves, right? That's 2 times 3 multiply themselves, and then square root of those that are inside, they multiply themselves. That's 5 times 10. At the end of the day, what do we have? We have 6 outside and we have 50 inside. So yeah, so we have 656 with 50. We need to reduce it to the simplest form. So reduction is what will help you here. So but then we have actually understood that we just use the calculator. This root 50 give me 30 root 2. Watch the reduction video again if you want to understand how these things are, the reduction method is working. So 30 root 2. Yeah, then we quickly have our final answer. So for multiplication of sets, those that are inside the bracket multiply among themselves, those that are outside also multiply among themselves. But if it is one and those things, like quickly we just reduce it. So the books, right? When you are reading the books, those things happen, but you won't really get it from the book that that's actually what is actually happening. So it's good to understand how they're actually working and how the principles still hold for all of them. But because of one, they usually ignore them. But then they exist, the rules still hold. So, but this is how to explain that. So from now on, when we have the root 3 times root 6, we're just going to have like root 3 root square root of 3 times 6, which is 8 is straight, because we know the other one. We know that once one are there. Now we look at multiplication of sets, right? Might come in different ways. It might come in a sense that you have to expand. Expansion. This is what comes mostly like 2 minus root 5 multiplying 3 plus root 2. Something like this. They are multiplying. This bracket is multiplying this bracket. So multiplication idea is there. But then there's addition and subtraction also over there. Now, so this is one term, right? This is another term. This is one term. This is another term. When we say a term, right? When you have numbers, a term is separated by a plus or a minus sign. A plus or a minus sign. So you have a plus b. There are two terms here, term a, term b. The plus is the one that separates them. If you have a plus b plus c, there are three terms here. There's one here, two here, three here. So a plus b minus c, there are still three terms here. One here, one here, one here. So there are three terms. So if you have a times b, right, plus c plus cd, there are still three terms here. A times b is like a times b, multiplication. Multiplication doesn't give you the difference in the term. It's only addition, subtraction that make you see this is a term, this is a term, this is a term. So a times b is a whole single term on its own, one block like that. So this one is one term, this one term, this one term. So we got that. And we are going to use that idea when we are doing the expansion. Let's do a bit of expansion. So let's use this example. We know how to do expansion. Now you have to take one element in one group and be multiplied by each element in the other group. So if you don't know expansion, please go and revise how to do expansion, because that's what we are basically using here. 3 root 2 multiplying 3 plus, I'm just using any example, 2 root 2. Yeah, it's an example. But then we need to also keep in mind is that when square root of 2, right, is multiplying square root of 2, the answer is 2. Basically, when you have square root of a number, multiplying itself, right, we are square root of itself, we are going to have a. I'm not talking about a root a. A root a is different. The square root of a is multiplying square root of a. It's not like a times root a, then you go and say it's equal to a. It doesn't happen. So they should be the same, like square root of a multiplying square root of a. That same thing multiplying itself, then you get a. But a root a is still going to be a, like 3 times root 3. The answer is 3 root 3. But root 3 times root 3, the answer is 3. Yeah, that's how it works. So, but then what's actually happening over here when we are done with this topic, right? We are kind of doing the basics. When we are done with the topic, there will be a section that will a video that we'll do for extra on sets, then you look at that and you see why the things are happening like that. But we know that a set multiplying another set will give you this. Yeah. So yeah, let's look at our example now. Now let's expand. 2 times 3. So I'm having 2 times 3 here. So use to multiply the other term. The other term, this whole thing is a whole term, plus 2 times 2 root 2, because this is multiplying the other term, plus this time is this is 3 root 2 multiplying 3, then this term plus this term times this term, sorry, you're having 3 root 2 times 2 root 2. At the end of the day, what do we have here? So next line we have 6 here, plus for multiplication we say those outside multiply among themselves. 2 times 2 is 4. For root 2, root 2 will just be there because it's the only one. There's no others. We are just focusing on this bracket. Yeah, plus 3 times 3 is what? 9. So we are having 9 root 2 here, plus this multiplication, right? Those outside multiply among themselves. So what we have, 3 times 2 is what? 6. And those under the square root multiply themselves. That's 2 times 2. But then it's root 2 times root 2, right? Root 2 times the root 2. That's what we said over here. The answer will be what? 2. If the same thing is the same root is multiplying each same root itself, we are going to have the answer to be just be 2, like that. So here the answer is 2. So if the same root is multiplying itself, root 2 times root 2 is going to be 2, root 3 times root 3 is going to be 3. Yeah, in that order. So now let's put things together. So 6 plus, oh, this is, we are removing the bracket, plus 9 root 2 plus 2 times 3. You can use your calculator alongside, right? 2 times here is 12. So what we have to group like them, 6 and 12. What do we have? 18, plus, because these ones are just whole numbers, so they don't have any roots, so you have to see them. Remember, for addition, right? For addition, what happens is that the roots, right? The square, those are numbers under the square root, they don't interact. But it's only those outside, and for those outside, for them to interact, the roots must be the same. But here the roots are, this one and this one are having the same root, so we can add. So the outside are qualified to be added. So at the end of the day, you have 4 plus 9. Watch the previous video on these addition things. Then you have this. So at the end, you have 18 plus 9 plus 4 is 13 root 2. Yeah, this is what we have for this expansion. And from here, you can see that you cannot further simplify it. And that's the final answer that we have for that expansion. We are doing addition, so we cannot add them together because what? For addition, we have a condition. So go back and watch that one. Now, let's try and solve another expansion, a simple expansion that we can, or maybe, so I have root 2 multiplying 3 minus 3 root 2. Yeah, so this is a simple expansion, right? For this simple expansion, there's only one thing outside here. So this one thing outside, expansion again. So we have to revise your expansion. This one will multiply this, and this one will multiply this guy. So for that, we have root 2 multiplying 3 plus root 2, right? Multiplying what? This is what? Negative 3 root 2. Remember that. We said when you are doing multiplication, right? When you are doing, you multiply by a term. And then when you have a term that's having negative in front of it, the negative is taken alongside so that we just avoid everything. Right? The negative, so this whole thing, the negative, why if it is positive, we just take the 3 root 2 because it doesn't. Why if it is negative there, we have to maybe take it all along as one thing. So now if you do this, here root 2, right? The one outside here is 1. So those outside multiply among themselves. We are going to have 3, and root 2 is just itself over the root 2. Focus on the bracket at a time. Plus, now in this bracket, root 2 times this root 2. Root 2 times this root 2 is root 2 times root 2 is what? So if the same root is multiplying itself, the answer is 2. So it's 2 times, here 1 is outside here, negative 3 is outside here. So it's going to be negative 3, like that. So at the end of the day, we have 3 root 2 here, and then this outside, 2 times negative 3 is what? Negative 6, plus negative 6 here. Then we soon have positive times negative. We have 3 root 2 minus 6. So this is our final answer because we cannot further simplify them. Yeah. So um for your expansions, right? For your multiplication and expansions, what we said is what if you are doing expansion or multiplication of sets, those under the square root multiply among themselves, and those outside also multiply among themselves. When you are done, the answer that you get, you try to use your reduction method or whatever method. If it doesn't switch, then you just leave the answer like that. So simply put, when you have 2 root 5 multiplying 3 root 20, for example, then what do I have? I will multiply the outside ones. So that's 2 times 3, and then inside ones 5 times 20. Yes, so when they do that, we have 6 square root of 100. Now square root of 6 square root of 100. Can we do reduction on this side? Reduction on this side. So basically we can do it. So it's going to give you 10, but just put in calculator 6 root 100. I have 60. So you have 60. So you have 60. Yes, so we have our 60 as our final answer for that expansion. So whatever you get at the end, when you simplify it, is good. If it doesn't simplify, you leave it as how it is. Yeah, so this is the idea about multiplication, right? So that's how it is different from the addition or subtraction. Yeah, so we'll use all these things together in going forward, but then we need to look at division as well. We are just looking at the basic operations on sets: addition, subtraction, which we've done already, and this one is for multiplication. The next one we are going to start with division. Division requires a previous information or something, a concept in set, which is called conjugate sets. So that's what we'll look at next time before we delve majorly into division of sets. So yeah, we'll see you in the next video. Let's like the video, let's subscribe so that we can actually build on the concept moving forward. Watch the previous video if you haven't, because there are concepts there that you might think you may not need, but they are very helpful so you understand how the things are connected when you're handling sets. Yeah, thank you very much and see you in the next video.